Okay, hello everyone, good morning. So, where the Ethereum protocol is going. So, I think we have seen a lot of big changes in the Ethereum ecosystem over the last couple of years. I think we've also seen a lot of changes happening outside of the Ethereum ecosystem, including what's become possible with AI, including quantum computing, potentially coming up very soon, including advances in formal verification, including cryptography, zero-knowledge proofs. And I think one of the things that we have been really doing a lot of is rethinking, like what really makes sense to use Ethereum for. Why does Ethereum, like what properties does Ethereum need to have? Why Ethereum needs to have these properties, and like how this fits into the roadmap for the Ethereum protocol over the next 5 years. So, what is Ethereum for, right? I think of it as having two big functionalities. So, one is that Ethereum is a public billboard. So it is a place where applications can post messages, and everyone sees what messages were posted in what order. These messages can be anything. They can be transactions, they can be hashes, they can be encrypted data, they can be many other things. And actually, there's a lot of opportunity for applications to use both Ethereum as a place to post data, and at the same time, other kinds of protocols to interpret that data, to decrypt the data, to do computation on that data. And then also the second is the computation, right? So basically, what Ethereum lets you do is it lets you have shared digital objects that are controlled by code. These digital objects can be many things. They can be ETH, the asset. It can be ERC20s. It can be NFTs. It could be NFTs that have meaning outside of Ethereum. So ENS is one example. It can also even mean control over organizations. So things like DAOs are one example, but you can do many things. So both of these are highly valuable for decentralized applications that guarantee self-sovereign security, verifiability, and fair participation to all of their users. So what do we mean by this? So self-sovereign basically means you as a user can participate, can verify, can be sure that you are secure, all with your own infrastructure. You do not need to trust any third party. You do not need to trust a third party to run Ethereum, and you also should not need to trust a third party outside of Ethereum if you do not want to. So verifiability, the ability to verify that the chain is progressing correctly, and to verify that everything that's happening is what is supposed to be happening, and also the ability to guarantee anyone's right to actually publish messages to this billboard. So this is the core. We should think of Ethereum as being a technical building block, and think about all of the what kinds of applications this technical building block enables. Most interesting applications will be a combination of on-chain and off-chain. This includes ENS. This includes prediction markets. Prediction markets have an on-chain component, which is the assets that they create for every event, the ability to trade those assets. Also, they have off-chain components. One of them is the Oracle. Another one is that sometimes there's prediction market designs where trading and order matching happen off-chain. And then also anything with privacy. So for example, there has been decades of work on cryptographic protocols that make it easy or that try to enable secure electronic voting. And a lot of these protocols, they often rely on a public billboard, a place where people can post information. In this case, they are encrypted votes. in a way that guarantees everyone's ability to participate. Anything with privacy has to have an on-chain part, publishing data on-chain, and an off-chain part, interpreting that data. Interpreting the data has to happen off-chain in a private protocol. So we talk a lot about L2s, and the way that I think about L2s and the way that I think about the types of L2s that make sense is that I think the type of L2 that does not make sense is just you take Ethereum, you make a clone of Ethereum, you make it 100 times bigger, you make it more centralized, and you are done. The type of L2 that I think makes sense is you start to look through these applications, you ask, what are the off-chain components that they need? What are the parts that they need other than the Ethereum L1? And then you build that. So what this means for Ethereum, we need scaling for data. We need the ability to publish much more data on-chain. And PeerDAS, which came in the most recent hard fork last year, already includes that, but we still need to push that further. Scaling of compute is also important because scaling compute that is part of the Ethereum chain allows different applications to compose with each other, to talk to each other without requiring intermediaries. Now, this is the straw map. If you go to strawmap.org, you can find this. This is a proposed roadmap for the next 5 years of Ethereum. So the core goals for the protocol in the short term, one is short-term scaling, continuing to aggressively increase the gas limit. One of them is to begin the ZK EVM rollout. I'll talk about this. ZK EVMs allow Ethereum to scale much more, have much more computation, while still making it very easy to verify the chain. Early post-quantum readiness. We have been thinking about quantum computing for years. We have recognized for years that it is a problem, and we have some things very soon in the short term that will improve Ethereum's quantum safety, and the entire roadmap already, this roadmap, by the end of it, Ethereum will be fully quantum safe for all parts of it and very efficiently. Improving the block building pipeline and improving support for privacy. So short-term scaling, there are a number of EIPs, proposals that will go into the next Ethereum hard fork, block-level access lists, which enable parallelization, gas repricing, which enables more efficiency. It also makes it safer for gas limits to be higher. EPBS makes it safer for it to take longer to verify Ethereum blocks, and improvements in Ethereum's ability, and Ethereum node's ability to download the state. EIP 8141, this is the account abstraction proposal. It's both very simple and very powerful. Basically, a transaction is a list of calls, and so one of the calls could be verification, one of the calls could be execution, and this makes it very easy for Ethereum to have native support for smart contract wallets, for paying for other people's transactions, for quantum resistant signature algorithms, and for privacy protocols. So this makes Ethereum more general purpose, and so it supports many functionalities at the same time. Quantum resistance. So quantum resistant signature algorithms exist. They have existed for 20 years. We know what they are. We know how to build them. The problem is that they are less efficient. So a quantum resistant signature takes 2 or 3 kilobytes compared to 64 bytes right now, and it takes 200,000 gas on chain compared to 3,000 gas on chain right now. And so there are 2 types of signatures that we can use. One of them is hash-based, the other is lattice-based signatures, and then the idea is that we add vectorization into the EVM, basically the same kind of logic that allows computers to run AI very quickly. We used basically process many numbers in parallel at the same time. The same logic can be used for lattice-based signatures, basically working aggressively to make quantum-resistant signatures much more efficient. Midterm goal, the state. So the state stores Ethereum accounts, balances, smart contracts. Scaling execution is easier, scaling the state is harder. There's a lot of work that we have to do on this. So that is all the short term. The longer term, and this is where we really want Ethereum to go, right? So Ethereum is not meant to be, is not meant to compete with high-frequency trading platforms. Ethereum is not meant to be the fastest chain. Ethereum is meant to be the secure chain, the decentralized chain, the chain that continues to be online, the chain that you can rely on. So one goal is maximally safe consensus, meaning if the network is synchronous, meaning if the network does not have problems, it can survive 49% of the nodes having faults, and it can actually survive almost all of the nodes going offline. So same property as Bitcoin. And then if the network has problems, then you still have finality with 33% security. That's one. Part two is formally verify everything. And we've been aggressively starting to use AI to generate mathematical proofs that the software that will be running the long-term version of Ethereum actually has the properties that it is supposed to have. We've already made progress that would have been impossible 2 years ago. AI is progressing quickly, and so we are using that. Full quantum resistance, also maximum simplicity, keep long-term Ethereum as simple as possible, and maximally future-proof, right? So Ethereum needs to pass the walk-away test. Ethereum needs to be a platform that you can rely on, even if there are no core devs left, right? Because and this is the same thing that Bitcoin strives for. This is the same thing that you have to strive for if you want to be a base for long-term secure assets, for long-term digital objects. You need to be something whose ongoing safety does not depend on one team continuing to exist and one team always continuing to work. Lean consensus. So lean consensus takes the best of both worlds between the Bitcoin-style approach, that's called the available chain, and the BFT approach, that's the finality. It gets both with optimal security properties, quantum safe, and fast finality. So finality within 1 to 3 slots, basically expect the chain to finalize within like 10 or 20 seconds, maybe less. ZK EVMs let you verify the chain without having a big computer that runs everything yourself. Everyone should be verifying the chain before they trust it. Even your phone should be verifying your chain. Even IoT devices should be verifying the chain. And ZK EVMs are already sufficiently fast to prove real-time EVM execution. The goal this year is to make them sufficiently safe. And the goal this year is to start with small percentages of the network using ZK EVMs and then increasing that over time, and to move to ZK EVMs being the primary way to validate the chain by 2028. And so this allows Ethereum to scale much more, process many more transactions without becoming centralized. So what is the vision behind these things, right? So Ethereum is the world computer. Ethereum is both a global shared layer for making commitments, for publishing data that represents actions that different users wants to take. It is a place where you can publish data, where you can prove that data has been published, and you can also prove that data has not been published, and that is very open for everyone to use. And it's also a global shared layer for high-value, guaranteed execution of rules. Ethereum needs to be maximally robust and maximally easy to verify. I think in the future, with AI, it will actually be easier than we've imagined to write actually secure software if you want to be secure. But if people do not want to be secure, then software will have 10 times more bugs than before. It will be attacked 10 times more than before. And so Ethereum as a blockchain needs to be on the secure side first, on the decentralized side first. And when those things are guaranteed, make that security available to users as much as possible. So Ethereum is there to build decentralized applications that guarantee self-sovereign security, verifiability, and fair participation for their users. This includes financial, this includes decentralized social, this includes identity, this includes applications that have one part financial and one part not financial, which includes things like ENS, includes things like prediction markets, it includes many things. And Ethereum, it will make building applications that are like this easy and default. And this is the core goal that the roadmap for the next 4 years is designed around. Thank you.